Hi there, this is the review for the final exam, and I am the amazing Mr. Jansen. So away we go. If I look at this first one, I'm just using my properties of exponents here, or my rules of exponents. And I'm going to follow order of operations. I start inside the parentheses, so I do the 16 divided by the negative 8 is a negative 2. When I divide, I subtract the exponents, so 3 minus a negative 5 is going to be x to the 8th. That'll give me a y to the 5th and a z to the negative 7th. And just be careful with your signs there as you're subtracting those exponents. And now I'm going to raise everything to the 4th power. Negative 2 to the 4th power is 16. I multiply the exponents. And then the last thing I do here is I take care of negative exponents. Remember, I send those to the denominator. So it's all over z to the 28th, and that's it. Okay, so I start inside the parentheses. I do my division. Then I raise everything to the 4th power, so I'm just following order of operations. And after I'm done with all of that, then I go ahead and take care of those negative exponents. Okay? If I take a look at the next one, number 2, I've got the square root here, so I'm looking for perfect squares. And so when I see this thing, the 288 breaks down into 144 times 2. The x to the 5th I can break down into x to the 4th times x. And the y to the 10th is already a perfect square because it's got an exponent that's divisible by 2. And now I take the square root of each of these perfect squares. The square root of the 144 gives me a 12. The square root of x to the 4th is x squared. The square root of y to the 10th is y to the 5th. And I'm still left with a 2 and an x underneath my square root symbol. And that's it. All right? And number 3, it's the cube root. So I'm looking for perfect cubes this time. In terms of numbers, this is going to be a 27 times 3. For the variables, I just need exponents that are divisible by 3, so I'm going to break that down into x cubed times x squared. The y to the 10th, I'll break down into y to the 9th times y. And now I take the cube root. Sorry, I missed my cube root symbol. There we go. So now I take the cube root of each perfect cube. The cube root of 27 is a 3. Cube root of x to the 3rd is an x. Y to the 9th is a y to the 3rd. And then still under my cube root is a 3, an x squared, and a y. And that's it. And number 4, we're looking for the 5th root this time. So that means we're looking for perfect fifths here. And if I'm looking for perfect fifths, I need things to the 5th power that divide evenly into each of these values. For example, the 96, the perfect fifth that divides evenly into that is 32. That's 32 times 3. X to the 5th and y to the 10th are already perfect fifths because, again, with variables, we just look to see if the exponent is divisible by that root, which each of these already is. And now I'm going to take the 5th root of each perfect fifths. The 5th root of 32 is a 2. The 5th root of x to the 5th is x to the 1st. And the 5th root of y to the 10th is y to the 2nd. And then still trapped under my 5th root, it's going to be the 3, and that's it. Okay, just a 3. If I take a look at the next one, with the next one, basically when I have these rational exponents, remember a 1/2 power is the same as a square root. The 2/3 power is the same as the cube root, and also raising it to the 2nd power. So we're just going to plug these values in and then start doing these operations. So I have 16 to the negative 1/2 power times, that's going to be a 1 over 64 to the negative 2/3 power. The first thing I'm going to do here is go ahead and take that negative exponent, and the negative exponent is going to flip this thing. So this becomes a 1 over 16th to the 1/2 power. This one, the negative flips it, so it becomes 64 to the 2/3 power. And now from here, 1/16 to 1/2 power, that's the same thing as the square root. When I take the square root of that, it's 1 over 4. Over here, this one's a little bit trickier, but just remember, the numerator is the exponent, the denominator is the root. I'm going to start with the root. So essentially, the cube root of 64 is going to give me a 4. And then when I raise that to the 2nd power, it's going to give me a 16. Okay, so this gives me a 16. And now 1/4 times the 16 is just a 4. And that's it. In the next one, it asks me to solve this thing. And whenever we're solving, especially when we have complicated pieces like a square root, I want to isolate the square root. So I'm going to subtract the 3 from each side. That's going to leave me with an x minus 3 equals the square root of 4x. Now I can undo the square root by squaring each side. When I do that, x minus 3 squared is x minus 3 times x minus 3. That's going to give me an x squared minus 6x plus 9. And now I'm going to subtract the 4x from each side. And so essentially what I have is I have a quadratic that I need to solve. So I'm just going to factor this thing and set each factor equal to 0. When I factor it, that's going to factor into an x minus 1 and an x minus 9. And then I set each factor equal to 0. And now I solve each. Here I find out that x equals 1. Here I find out that x equals 9. And the last thing I might do here is check for extraneous solutions, which in this case there aren't any. I just have to be careful because of a square root. The square root, I can't plug negatives into that square root, so I have to toss any answers that don't meet the domain values. Okay? If I look at the next one's just asked me to multiply these two things. So I take the f of x function, which is the x squared plus x minus 5, and I multiply it by the g of x function, which is the x plus 4. And when I do that, it's simply just my distributive property. I'm going to distribute the x squared. That's going to give me an x cubed plus 4x squared. I distribute the x. That gives me an x squared plus 4x. Then I distribute the minus 5. That gives me a minus 5x minus 20. And now I just combine like terms. That's going to be an x cubed plus 5x squared minus x minus 20. And that's it. Number 8, I just want to divide this time. So I'm taking these two values and dividing. So I'm taking the x squared plus x minus 5 and dividing by the x plus 4. And for this one, I'm going to use synthetic division. So with synthetic division, remember I take the opposite of this guy and put it in my box because synthetic division is designed to check solutions. So put the negative 4 in my box. And now I need to write the coefficients of the thing being divided, but I need to have them in descending order. So I got to check to see if I'm missing any terms. Here I've got an x squared, an x to the first, and an x to the 0. So I'm not missing any. If I am missing a term in descending order, I have to put a 0 in its place. Since I'm not missing any, I just write down these coefficients. And now I bring down the first coefficient. I multiply what's in the box by what's underneath. And then I add straight down. What's in the box times what's underneath. And I add straight down. And now since I started with an x squared here, my solution starts with 1 less, so it's going to be an x to the first. So this is x minus 3 plus the remainder of 7. I put my remainder over the thing I was dividing by. Okay? Number 9, we're asked for the composition here. This is like saying f of g of 25. And really this is just a chain reaction of substitutions here. So I'm going to plug the 25 into the g function right here. So when I do that, if I take it off to the side, I plug the 25 into this function right here. So that's to the 1/2 power, and 25 to the 1/2 power is a 5. So what I end up with then is f of 5, and that's just telling me to plug a 5 into my f function, which is up here. So I'm going to do 5 to the 3rd power plus 1. So that's a 125 plus 1, which is 126, and that's it. So I'm just substituting one thing into the next thing. For this one, it says g of f of 2. So again, I'm plugging the 2 into the f function. So I'm plugging this into the f function. So I'm starting with the f function this time. That's going to be 2 to the 3rd plus 1, which is 8 plus 1, which is 9. So now what I have here is g of 9 when I substitute that in, which means I'm plugging a 9 into the g function. So I have 9 to the 1/2 power, which is a 3. All right? In the last one, it's just asking me to do f of g of x. In other words, if I plug an x into the g function, it's just going to be x to the 1/2 power. It's already written that way with an x in it. And now I'm going to plug that into the f of x function. So I'm going to have x to the 3rd power plus 1. But instead of x, I'm plugging in this x to the 1/2 power. And now it's just my properties of, or my rules of exponents. I multiply, that's a 3/2. I'm just going to leave it like that. If you want to write that as the cube root of x squared, that would be fine. Or sorry, the square root of x cubed, that would be fine also. Okay? If I look at the next one, it asks me to find the inverse. And remember, this is like saying y equals x squared minus 2. So to find the inverse, I just switch the x and the y values, and I solve for y. So here, if I switch x and y, that's going to be x equals y squared minus 2. And now I'm going to solve this one for y, so I'm going to add the 2 to each side. I end up with x plus 2 equals y squared. And now I take the square root of each side. And I just have to remember, since I took the square root of each side, I have to remember that I do plus or minus that square root. So it's plus or minus the square root of x plus 2. And that is important here because the original function is a parabola. And if I forget the plus or minus, I'm not going to have the entire inverse. The plus or minus gives me an entire sideways parabola as opposed to just half a sideways parabola. Okay, so don't forget that plus or minus when you take the square root of each side of an equation. For this one, again, this is just like saying y equals x to the 1/3 plus 4. The inverse tells me that I need to switch the x and the y, so I do x equals y to the 1/3 plus 4. And I'm just going to solve for y. So I subtract the 4 from each side. To undo the 1/3 power, that's like the cube root, I have to raise each side to the 3rd power. And you can see that when I multiply these exponents, it just leaves me with a y. Over here, I'm just going to go ahead and leave this as x minus 4 to the 3rd power. I'm not going to multiply that out. I'm going to leave it in this factored form. Okay? In the next one, again, this is like y equals 2 plus the natural log of x. I'm going to switch the x and the y, so I'm going to rewrite this as x equals 2 plus the natural log of y. And now I'm just going to solve for y again, so I'm going to subtract the 2 from each side. So I end up with x minus 2 equals the natural log of y. And to undo the natural log, remember, any logarithm I have, if I have log base 2, I do 2 raised to the power of each side, where each side of the equation becomes my exponent. This is natural log, so I have to do e raised to the power of each side. So I do e raised to the x minus 2 equals e to the natural log of y. And the natural log and e cancel each other out. So I find out that y equals e to the x minus 2. And that's it. If I take a look at the next couple, I'm going to graph each of these, just drawing a quick sketch so I can get my domain and range. So when I look at this, I should immediately recognize that this square root function is going to give me half a sideways parabola. My typical function would look like this. But since I have a negative inside where x is, it's going to flip it over the y-axis here. It's going to flip it horizontally. So it's going to look something like that. And so now I take this and I identify my domain and range. The domain, the x values are all less than or equal to 0. And the range, I can see all the y values are greater than or equal to 0 because it goes up. And that's it. For the next one, this is just like the previous one, except I have a couple more shifts. Remember, the original function looks like this. Inside with the x, I'm subtracting 3, so that's going to move me to the right 3. So that would put me here. And then I'm going to move down 1, which is going to put me here for the start of my parabola, or half a sideways parabola. But instead of opening up, this one's going to open down because of the negative symbol. So it's going to look like this. Okay? And again, it's still that same shape, but it's been moved around a little bit. And now I can identify my domain and range. My domain is x is greater than or equal to 3, and my range is y is less than or equal to the negative 1. Okay? If I take a look at the next one, again, the original function, the parent function, would look like this. It's that twisted parabola. That's what x to the third functions look like. But this is negative, which means I'm going to flip it, which means this part that was going down is now going to go up, and the part that was going up is now going to go down, so it's going to look like this. That doesn't really affect my domain and range. As I look at this thing, the domain here is still all real numbers. The range is also all real numbers. Okay, so my domain and range for that one, all real numbers.